Welcome to your new unit, Radicals. On this slide, you can see a few examples of radicals. If you've seen these before, you've most likely seen square roots, and that's going to be our focus this year. Radicals are the opposite of exponents. So a square root is the opposite of squaring something, which we at this point are very familiar with. In math, it's pretty common for us to learn something and then learn its opposite. After you learn addition, that 3 plus 4 equals 7, you probably learned subtraction, 7 minus 4 equals 3. Now we've just learned exponents, such as 3 squared equals 9, and now it comes naturally that we'll learn square roots, that the square root of 9 equals 3. And in this video, you will learn a very brief introduction to the concept of square roots. During our exponent unit, we learned that 3 squared equals 9. This means that if I were to draw a square with a side length of 3 and another side length of 3, we would have 9 boxes as the area of that square. To take a square root is to say what number times itself equals our number. In this case, what number times itself equals 9. So therefore, the square root of 9 is 3, because if we have a square that is made up of 9 square units, then each of the side lengths is 3. Let's look at another example we know. We know that 5 squared, or 5 times itself, is 25. This means that if we were to draw a square that had side lengths 5 and 5, we would end up with 25 square units inside. If I want to undo that, I would have the square root of 25. I could visualize it like this. And I would see that each of those side lengths is 5 units. Therefore, the square root of 25 is 5. Some people like to think of it like this. What number times itself is 25? And since we know that 25 is 5 times itself, we know that the square root of 25 is 5. Our goal today is going to be to fill in this chart in your notes. We're going to use what's familiar about squaring numbers in order to fill out the new column, square roots. So let's start about halfway down. We know that 5 squared, or 5 times 5, is 25. Therefore, the square root of 25 is 5, because 5 times itself, or 5 squared, is 25. We know that 6 squared is 36. Therefore, the square root of 36 is 6. We know that 7 squared is 49. Therefore, the square root of 49, which says what times itself equals 49, is 7. You can see how these are opposites when you look at the squaring numbers and the square root. And give yourself some credit. You probably already know a bunch of these. But if you keep scrolling down and look down your page, there's a bunch you don't know. So the goal is for you to memorize these, but right now we're just going to fill in the chart. Focus on your squares. We're eventually going to get to our cubes and to a few higher powers, just like we saw in exponents. If you get stuck, learn how to use your calculator to find a square root. Some calculators will look like that symbol, and some will have a little 2 next to it. Make sure that you test your calculator first. Some might have you type in 25 and then type in the square root button, while others, you'll type in the square root first, and then you'll type in the digits 25. You need to learn your calculator before you're able to use it to help you. Here's a square root in a different context. Have a great day.